8.4a from IGCSE Extended Mathematics that is recommended by AQA examinations. Our topic will be congruence and similarity. Before moving to the questions, we will see the difference between the congruence and similarity first. The congruent shapes have exactly the same shape and size, while in similar shapes, the shapes are same, but their sizes can be different. If we mathematically see the difference between the congruence and similarity, then in congruent shapes, all the corresponding sides and angles should have the same size. While in similar shapes, the sides ratio will be same, means the corresponding sides ratio will be equal, means proportional, and also the angles will be equal as the angles were equal in congruent shapes. We can also compare the congruence and similarity in this table, and we can see that these symbols are used. Now let's proceed to the questions. In question number 1, it says that PQR is an isosceles triangle, means have two equal sides. These two sides are equal. PQR is the isosceles triangle. And it says that S is the midpoint of PR, means S is dividing the shape of the triangle into identical halves. And similarly, we can also say that S is actually dividing the length PR into two equal halves. Now we have to prove that the triangle PQS is congruent to the triangle RQS. So for the triangles and for the congruent shapes, there are some rules. Like if we prove that all corresponding sides of both shapes are of same size, then we can say the triangles are congruent. And similarly, there are some other rules that we have seen in our previous slide. Let's compare two triangles. The first triangle is PQS and the other one is RQS. So these two triangles can be compared and we will check that are these two congruent or not. So first of all, in these two triangles, we know that the side PQ is equal to the side QR because of, that these are two corresponding sides. And by the way, due to the isosceles triangles, we can say that these two sides are equal. So we have to write the reason that due to isosceles triangle, these two sides are same, means equal length. And now we can also give the reason that as S is the midpoint of PR, so the length of the PS and SR will be same, means in these two triangles, these lengths PS and SR have the same size. And so why? Because it's given that S is the midpoint. Now look, in these two triangles, PQS and RQS, we can see that QS is the common side, means it is same for both, means in both triangles, QS is common, means both triangles have common side QS. So as we have proved three equal sides over here, so we can say that the triangles are congruent. So we can say the triangles are congruent. Now in B part, it says prove that the angle PSQ is a right angle. PSQ is this angle and we have to prove that it is of 90 degrees, means it is a right angle. As in A part, we already have proved that the two triangles PQS and RQS are both congruent triangles, means their corresponding angles will have the same size. Due to corresponding triangles, angle PSQ and angle RSQ will have the same size. And from the triangle, if we carefully observe that these two triangles are on the straight line, so the sum of these two angles, means PSQ and RSQ, should be equals to 180 degrees. Means we can replace RSQ with the PSQ because we already know that the angle PSQ and RSQ are of same size because of the corresponding triangles. So we can also write that angle PSQ and angle RSQ can be replaced with angle PSQ. So if we just solve it, we get 2 times the angle PSQ, means PSQ plus PSQ should be 2 times PSQ. And if we divide both sides by 2, we will get the size of angle PSQ and that should be 90 degrees. So we have proved that the angle PSQ is 90 degrees. Now let's proceed to next question. In question number 2, it says in rectangle ABCD, AB is the parallel line to DC and AD is parallel to BC and all angles are 90 degrees. So let's make a rectangle. This could be a rectangle and let's write the names, like this can be AB and this can be CD. So look, AB is parallel to DC and AD is parallel to BC, and all angles should be of 90 degrees, like here, and at each vertex we should have 90 degrees over here. So I have mentioned the angles which are 90 degrees. We have to prove the triangle ABD is the congruent to the triangle CDB. So ADB is the triangle when we make a diagonal over here. So let's make a diagonal. Means if we draw the diagonal, we get the triangle ADB and similarly CDB. So we have to prove that these two triangles are congruent. Again, if we carefully observe that in these two triangles, first we will write down that in triangle ADB, or we can also say ABD, and triangle CDB, we have to compare these two triangles and we have to prove that these are two congruent triangles. So look, in both triangles, we have DB as the common side. Means one side is common, which is DB, means have the same length. So common side has same length. Means in both triangles, DB is equal to DB. From the given statement, it says that all angles are 90 degrees. So we can also write that angle A and angle C are equals to 90 degrees. Means in both triangles, we have proved that these two angles are of 90 degrees, means these are two right angles. Now, from the given statement, we already know that the shape is the rectangle, means the opposite sides have same length. So we can also write that the side AB is equal to the side DC because of the opposite sides of the rectangle. So in both triangles, we have got two equal sides, means two corresponding equal sides and one right angle over here. So it means that these two triangles can be congruent because of RHS, means they are following this rule. So we can say from RHS, both triangles are congruent. In B part, they want us to write down the angle that is equal to angle ADB and BDC. So look, ADB is the angle with D at the center. So if we carefully observe that on these two parallel lines AB and CD, this blue diagonal is the transversal. So on the transversal, you can see that the angle which should be equals to ADB should be this angle, because this is an alternate angle to ADB. So we can write that angle ADB is equal to angle CBD because of alternate angles. And similarly, for BDC, BDC is basically this angle over here with D at the center, BDC. So its alternate angle should be DBA, or we can also say ABD. So because of the alternate angles, these two angles are also same. So we can write angle BDC is equal to angle DBA because of alternate angles. Now let's proceed to next question. In the guide ABCD, AB and AD are two equal sides, and BC and CD are also two equal sides, and we have to prove that the angle B and angle D are equal. So if we carefully observe the figure, this is a quadrilateral. And in our previous questions, we were proving the congruent triangles. So let's make a triangle over here that will make easy to prove that angle B is equal to angle D. Means when we will draw a diagonal AC over there, that will divide the shape into two identical triangles. And then we can apply some rules to prove these two triangles congruent, and it will give us the corresponding angles equal, means we can prove required statement. So in this quadrilateral, we did some construction that we draw a diagonal that joins AC. And after making a diagonal over here, it splits the shape into two triangles. So now we will compare these two triangles, ADC and triangle ABC. So look, in these two triangles, it is given that the side length AB is equal to AD. It is already given. So in these two triangles, these two corresponding sides are equal. Similarly, it is also given that the side length BC is equal to CD. Look, this diagonal is common in both triangles ABC and ADC. So that's why we can say that AC is equal to AC. We can write that this is a common side. So after proving three equal corresponding pairs of sides, we can write that the triangle ADC is congruent to the triangle ABC. So as we know that in congruent shapes, all the corresponding parts means angles or sides are equal in length. So we can write that the angle B will be equal to angle D because of corresponding angles of congruent triangles. Now let's proceed to next question. In question number 4, it says the diagram is 10 centimeter wide and 12 centimeter high. Means its width to height ratio is 10:12. And a photocopier is used to reduce the size of the diagram. Find the new height of the diagram when the new width is 8 centimeters. So let's write here that if the width becomes 8, then what will be the height of it? So for this purpose, we can do cross multiplication because you know that if we write the ratio of the width, so the ratio of the width becomes 10/8, and we can equate to the ratio of the heights that should be 12 over unknown height. When the width becomes 8, then we don't know the height. So for this purpose, we can equate both ratios and then we can do cross multiplication. Then let's suppose this is unknown, means this is x. So we can write 10x. This could be x. So we can write 10x equals 12 times 8, and that should be 96. So 10x equals 96, and if we want to find the value of x, means the height, it should be 9.6. It means when the width becomes 8, the height will be 9.6. So the height will be 9.6 centimeters. Now we have to find the new width of the diagram when the new height is 8 centimeters. We will use the same ratio of the width and height, that was 10:12. But this time we want to find the width that can be called as y, and the new height is 8 centimeters. Again, we can do cross multiplication, means the ratio of both width and height should be same, means 12/8. So let's solve it. We can do cross multiplication. That can be 80 equals 12y. And if we divide both sides by 12, we will get 80/12, and the y will be 6.67. So when the height will be 8 centimeters, the width will be 6.67 centimeters. I just rounded off this value. Let's proceed to next question. In question number 5, it says a miller sells corn flour in small packs as shown. The miller wants a similar catering pack to hold 64 times as much. Means he wants to increase the capacity of the container, means 64 times more. So look, when you take the capacity, then means we are actually considering the volume over here. So he actually wants to increase the volume by 64 times. Volume scale factor is 64. So we have to actually work out the new dimensions that will increase the volume 64 times more than this. Like currently, whatever the volume is, we just want to increase it by 64 times. So we have to find the new dimensions. So let's, before finding the new dimensions, first we need the linear scale factor for the dimensions. We know that the volume scale factor, I'm using VSF for the volume scale factor, will always be the cube of the linear scale factor. Linear scale factor. I know the volume scale factor, which is 64. So to get the linear scale factor, I should take the cube root on both sides. So I'm taking cube root on both sides to get the linear scale factor, and that should be 8 over here. Now we will multiply each dimension with 8 to get new dimensions. New base should be 8 times 8. That should be 64. Mean this dimension will become 64 centimeter. Similarly, the new width, which is currently 4 centimeter, but new width should be 8 times 4. That should be 32 centimeter. Similarly, new height will be 8 times 15, and that will be 120 centimeter. So now we have got the new dimensions. Let's move to next question. In question number 6, a shop sells picture frames in the following sizes. We have following sizes with the width and heights, and which of these sizes are similar in shape? So for the similar shapes, the ratio should be same. So let's find the ratio of each. So in the case of mini, the width to height ratio is definitely 4:5, because if we divide both numbers by 6, we get the ratio 4 and 5. Similarly, in small size, the width to height ratio should be 3 and 4. We are dividing by 10 over there. We are actually dividing by the highest common factor. And in the medium size, the width to height ratio should be 4 and 5. Again, we are dividing by 10. In the large size, the width to height ratio should be 5 and 7. And in extra large size, the width to height ratio should be 3 and 4. Because here we can divide by 20, means 20 is the highest common factor over there, so it will give us 3, 4. So look, which of the following sizes have same ratio, means width to height ratio. So now we have to decide that which of the following sizes are similar. So definitely we need to look which ratios are same. So look that the mini and medium have same ratio, so these are similar in size. And also the small and the extra large sizes are also similar in shapes because they have the same ratio. So we can write that the small and extra large are also similar in shape.